Good day, Year 11 Maths students. This is the first video for Chapter 3. Today we'll be looking at quadratics with expanding and collecting like terms. So first one, we have the polynomial function. So what is a polynomial function? We have the word poly. Okay, it refers as many. Nomials means terms. Okay, so there are many terms. So we have a function that contains multiple terms, where n is any natural number or 0. And then all the a's, a0, a1, all the way to an, they are our coefficients. Okay, they are coefficients. So here we can give you an example. Okay, you can write y equals to 2x squared plus 3x minus 2. This is example of a polynomial function. You can also write as simple as x. This is also a polynomial function, and given that the coefficient is 1, which is the number in front of the x, and the highest power n, it is also equal to 1, which means the rest of the terms all have the coefficient equal to 0. That's why it's only x here. Degree. Okay, now what is meant by degree? The degree of a polynomial is given by the value n, the highest power of the x with a non-zero coefficient. Okay, so here I can give you y equals to 0x to the power of 3 plus, let's do it, minus 2x squared plus 3x minus 4. Okay, so here 4 is actually x to the power of 0, as any non-zero base to the power of 0 equals to 1. Okay, so what this degree means, it's going to be the highest power of the variable x. However, the coefficient must not be 0. Therefore, this is excluded, as the coefficient of x to the power of 3 is 0. It's just negative 2x squared plus 3x minus 4, yeah? This is just 1, right? Minus 4. Therefore, the highest power is going to be 2. A polynomial function of a degree 2 is called quadratic function. The general rule of a quadratic function is in the form of y equals to ax squared plus bx plus c, where a cannot be 0, because when a equals 0, the x squared term is gone, and you only have bx plus c, which we simplify into a linear relation. The graph of a quadratic function, it is called a parabola. So here we have some general binomial expansion concept. Okay, if you have a plus b times c plus d, you will expand this way. Okay, so more familiar way that we use is called the FOIL. So what the FOIL mean? F stands for front, O is outside, in is inside, and this is last. It means we have to do these two first. This is your front, F, and then we do these two. This is the outside, because they're outside of each of the bracket. And then you do these two here. These are the inside. And then we do these two in the end. This is last. Okay, so this is called FOIL. Later on, I'm going to show you examples how we're using FOIL to expand brackets. The second one is a formula. Okay, so it is basically a summarized formula from the FOIL if the two brackets are exactly the same. So we can just do this. So a plus b squared, we can just rewrite as a plus b times a plus b, right? So in this case, we're using FOIL, we get a squared plus the outside, which is ab, plus the inside, which is ba, we write ab as well. And then we have the last, which is b squared. The middle two, that we can collect the like terms into two lots of ab plus b squared. So this is, in fact, the formula of the perfect square expansion. The last one, the difference of two square expansion, or we sometimes call this as DOPS, is also a summarized formula from the general expansion with using the FOIL. So if you have a plus b, a minus b, notice you have the two brackets that contains the first pronumeral is exactly the same, the second pronumeral are exactly the opposite, okay? Exactly opposite. You have the plus b and you have the minus b. Now watch what we do here. So firstly, using the front, a times day is a square. And then the outside, so this is a square. And then the outside, we've got, it's a times negative b, which is plus a negative b, yeah? And then we have here plus ab. And then we have the last is plus b negative b. Okay, and then we simplify, we have a squared. Now plus a times negative b is minus ab, and then you have plus ab, and then we have minus b squared. Okay, these two will get cancelled, and then hence you're only left with the two square term, and then there is a minus sign in between. That's why we call them as difference of the two square terms. Okay, so those are the key ideas for chapter 3a, expanding and collecting like terms. Let's take a look about a few examples. Now let's take a look about these three questions in example 1. So the first one, make sure that when you expand in brackets, you always need to identify the terms that contains the negative sign, and always carry that negative sign along the way when you're using the distributive law, okay? So here we can see that the negative 5 is the factor that is going to be multiplying brackets of 4 minus 2x. So when we expand this, it's going to be the negative 5 multiply each member or each term inside of the brackets. You can write as what I'm doing here by covering negative terms with brackets. So you have negative 5 times 4 and then minus negative 5 times 2x. So let's slow down a bit, make sure each question that we do is all correct, okay? So you have negative 5 times 4, you get negative 20. And here you have a minus a negative. You have two negatives equivalent as a plus. So plus 5 times 2x, which is 10x. So often we will put the x terms in the front. So you have 10x minus 20. Because we often place the terms in a descending order of the variable. Let's look at the second question here. Second question, notice that negative 5 is not being used at the first step. So what we do is we're going to keep the negative 5, copy it down, and then you have to minus, okay? So before we do that, we can rewrite this as a plus. We can consider this as a plus or negative 2 term, okay? So you plus a negative 2 times 5 minus 3x. In this way, we know that it's not the 2 I'm multiplying with each of the term in the brackets, it is the negative 2 that I'm multiplying. And then we got negative 5 plus negative 2 times 5 minus negative 2 times 3x. Now I get negative 5, okay, plus negative 2 times 5, which is minus 10, yeah? Because it's a plus negative 10. Let's write a plus negative 10 first. And then here we have minus negative 2 times 3x, it is negative 6x. Now, we got negative 5 plus negative 10, which is minus 10, minus negative 6x is the same as plus 6x. So you have minus 5 minus 10, in total is minus 15, plus 6x. And then we rearrange, make 6x minus 15. Last one, we got two brackets, okay? So we just expand the first one by saying it's a 3 times each terms. And for the second one, we will write as plus negative 6 times each one, yeah? Times each one, okay? So we're going to write as 3 times 5x minus 3 times 2, and then plus negative 6 times x minus negative 6 times 1. So then you have 3 times 5x is 15x, minus 3 times 2, which is minus 6. Now plus negative 6 times x is plus negative 6x. And then you have minus negative 6, because negative 6 times 1 is negative 6. Then we have 15x minus 6 plus a negative 6x is just minus 6x. And then minus a negative 6 is just plus 6. Okay, now we have a minus 6 and plus 6. They can get cancelled. We have then 15x minus 6x, and you got 9x left. Now let's look at the second example. Second example contains 4 questions that you need to expand a binomial product expression. So the first one, we're just using FOIL, okay? It's going to be the front, that's the front, and you have the outside, you have the inside, and you have the last. Yeah. So if you have front, which is 2x times x, and then you have the outside, which is 2x times negative 3. And then you notice that I always using a plus, okay? So in polynomial terms, you're always using plus. And then you plus the inside, which is 10 times x. And then you plus the last, which is 10 times negative 3. Let's simplify each of the terms here. 2x times x is 2x squared. And then you plus 2x times negative 3 is negative 6x. And then here you have 10x. And the last one you have negative 30. And then let's simplify the sign here. You have a 2x squared plus a negative 6x. It is the same as minus 6x. Yeah? And then you have a plus 10x. And then you have a plus negative 30, which is the same as minus 30. You have a minus 6x and plus 10x. These two are like terms, so we can combine them, which give us 4x and then minus 30. Okay, so you should end up with 3 terms here. Okay, now let's look at the second one here. The second example, it is again a binomial product expression. However, here we have a third. But don't worry, if you got a third, you just still multiply them. So here again, the front, the outside, the inside, and the last. Okay, follow this order. So firstly, let's write 5x times 2x. Okay, so that's the front. And then plus the outside, 5x times square root of 3. And then you have the inside, negative 3 times 2x. And then you have the last, which is negative 3 times root 3. Okay, that's the last. Simplify each of the terms. 5x times 2x, we get 10x squared. And then we have 5x times square root of 3, which is 5 square root of 3, or 5 root 3x. And then we have a negative 3 times 2x, which is negative 6x. And then we have the last one, which is plus negative 3 times square root of 3, which is negative 3 root 3. Yeah. Okay, now let's continue. Simplifying the signs. We have 10x squared plus 5 root 3x. Okay, and then plus a negative 6x is the same as minus 6x. And then we have plus a negative 3 root 3 is just minus 3 root 3. Okay, now let's combine them. Let's write 10x squared. Okay, so we have, this is the common one, right? The collecting the like terms. So we take the common factor of the x and then put the coefficient for both in the brackets. A third question here. Third question, we notice this is a perfect square. So we're using the perfect square formula here. Okay, so I'm going to just recall the perfect square formula. A plus b squared equals to a squared plus 2ab plus b squared. Okay, now for this one, we got to recognize the whole thing here. 2x is going to be a. Negative 1/4 is going to be b. All right. So we can rewrite this expression as 2x plus negative a quarter. So it's going to be the a squared, so which is 2x squared, and then plus 2 lots of a, which is 2x, and then times b, which is negative a quarter. Okay, and then you plus b squared, which is negative a quarter squared. Now let's simplify each of the term. You have 2x squared, which means it's going to be 2 squared x squared, so that's 4x squared. Okay, don't just make a 2x squared because 2 and x are sit together inside of the bracket. This 2 is going to be distributed to each one, okay? And then you have 2 times 2x times negative 1 quarter, which is negative x. And then you are adding negative quarter times itself. So negative times negative becomes positive. A quarter times a quarter is 1/16. And finally, simplify the signs here. You plus a negative x, it's minus x, plus 1/16. All right, next one. The last one here, we notice here, these two are exactly the same. These two are exactly the opposite, okay? So then we know that we're going to use in the dots, which is, the formula is a plus b, a minus b, it is equal to a squared minus b squared, okay? So then we're going to use in the formula here, so we recognize that's going to be 3x squared minus b is going to be 5, right? So minus 5 squared. Okay, again, 3x squared is not 3x squared, it's going to be 9x squared because 3 have to be squared as well. Okay, minus 5 squared, which is minus 25. And this is the simplest. This is how we expand in the brackets, collecting the like terms. Thank you for watching, guys, and looking forward to seeing you in the next video.